Good afternoon, class. So in today's video, what I'd like to do is my shout out video to period 7, chemistry period 7, school year 2025 to 2026. So in this video, we're going to be doing number 38 of the 100 chemical reactions that I have assigned for homework. But if you're looking at it just from a packet standpoint, this would be chemical reactions number 21 to 40. This is number 18. So whichever way you want to identify which problem this is, here we are. So we've got a hydrocarbon plus oxygen gives us carbon dioxide and water. What type of chemical reaction is always the first question that we should ask, and that is combustion. Mostly you can tell that because carbon dioxide and water are the products. You can also tell because oxygen is being added to a hydrocarbon, but mostly it's the products. So now when we solve for this, what are we going to do? We could use method number 1, the traditional method, but in this case, maybe it might be easier because of all the crazy subscripts here to use method number 2. I could try method number 3, but that's best suited for ionic compounds, and there are no ionic compounds in this reaction, so method number 2 it is. And all it is I just take each of these horizontally written elements with their subscripts and I just write them vertically. That's why I have C5H9O. Instead of writing it horizontally, I wrote it vertically. And the reason why that works, for me, at least it helps get me to think about what's going to happen, is that I can now say, if I put a 1 here, then I can say, okay, I'm going to put a 1 here, 1 here, 1 here, because all of those things would go together. So that's what that's how I would say that that's the advantage over the traditional method, but it can be whatever your preference is. There is no real change, or there's no real anything that's wrong with the traditional method. This is just another way to do this. However, what I need to watch out for in this case is because you see this odd number over here, all of these odd numbers, it does make it a little bit difficult. We have to think about where everything is going, because you see these even numbers over here? If the odd numbers don't balance out with the even numbers, this equation will not be balanced. So we need to be careful of that and cognizant of that. And so the first thing I'm going to take a look at is there's H9 over here. This H9 is a problem because it's odd, and there's only H2 on this side. So then you might have to, so then we would take a look at it and say, okay, what can I do? So clearly this needs to be at least a 2 in the coefficient. Oh, but wait, if I do that, then when I take a look over here, that means that this coefficient must be 9. And if that coefficient is 9, when I look at the totality of the oxygens on this side, 9 plus any even number will still be odd. And the problem is on this side, I've made this oxygen even because of the 2, and this O2 will only ever be even. So I'm a little bit stuck. I made a wrong guess. So therefore, I need to go back and say, this 2 is also not a good place to start. I probably need to start with 4. And so I will start with 4. Let's see where this goes. And we can kind of Sudoku this a little bit. We get clues. Once we take our guess, we get some clues, and then we get some more answers later on. So when we put this in, we're going to put our 4 and just fill in that box and say, okay, let's see what we got. Because we've got, let's look at our carbons right now. 5 times 4 is 20. So therefore, we look over here and we say we need 20 as our coefficient over here. The reason why is because the carbons are only over here on the reactant side. So on the product side, there have to be an equal number of carbons. So therefore, 20 on this side, 20 on that side. And because the O2s are chemically bound to the carbons, that is also going to be 20 as well. So there'd be 20 pairs of oxygen so far. Next, we go to the hydrogens. 9 times 4 is 36. So therefore, how many pairs of hydrogens do I need to make that work? That would be 18. And 18 over here, 18 over here for our coefficient for the water molecules. So, hey, what do you know? We have the whole product side all worked out. The carbons are good, the hydrogens are good. Now we need to figure out how the oxygens balance out on this side versus this side. So let's take a look. 20 times 2 is 40, and 18 times 1 is 18. 40 plus 18 is 58. So now we take a look on this side and notice that 58 is an even number, and we have a pair of oxygens, which means all we need are an even number of oxygen atoms, and we are good. So the last thing I have to do is say, I've got 58 on this side, I've got 4 over here, so therefore I need to subtract that to find out how many pairs I need over here. And so I've got 58 minus 4 is 54, and so we divide that by 2 to get 27, and therefore this is the balanced form of this reaction. One way to check this, how do I know that this actually is balanced? Because couldn't I just simply reduce any of these? Like I've got 4, 20, and 18. This is true. They're all divisible by 2, except this coefficient over here of 27 is not divisible by 2. So therefore, because I have at least one odd number mixed in with some even numbers, this must be as simple as it gets. Looks complex, I know, but at least it is simplified and balanced as much as possible. So therefore, this is the answer to number 18 from chemical reaction problems 21 to 40. This is your shout out video to period 7, 2025 to 2026. Study hard. See you in the next video.